Hello, my name is Daniel Grimmer. This is part 4 of a talk on evolutionary epistemology in Silico. We're talking about how neural networks can teach us things about nature and nurture. So, to recap, I introduced the topic about how I'd like to take empiricist tools and turn them towards nativist ends, in particular in answer to a complaint that Chomsky had about large language models. I introduced some evolutionary meta-learning techniques. Then I applied them to LLMs to sort of give an answer to Chomsky that I think we can evolve a universal grammar or something much like it inside of a large language model. But we can apply this to any kind of nativist program, be it Kantian categories or intuitions or Jungian archetypes perhaps. And so I'd like to spend the last portion of the talk talking about how we might evolve a spatial intuition inside of a large language, not a large language model, but a transformer. Sorry, it's very similar, but it's not processing language. Consider, for instance, Othello GPT. The board game Othello, sometimes called Reversi, is played on a grid. You place black and white stones. When you surround some stones in a line or diagonally, it flips all the intermediate stones over. And it can have this interesting global effect on the board from a local play. So learning the board state from the sequence of moves is not an easy task. But they trained a network, a transformer, to do this. It was trained on sequential, non-spatial data, and it wasn't trying to predict the board state. That wasn't the goal. It was trying to predict the next move or predict which moves are legal. There's different variants of the setup, but it's trying to take a string of input moves, tokenized, and produce an output move, just a token. So tokens in, tokens out. If it comes to understand the spatial representation of the board, it does so as a means of coming to do that next token prediction task, or that valid token prediction task. So they did this, and when they looked inside the weights and biases, they found that there was in fact a two-dimensional spatial representation of the board regarding which states were blank, which had black stones and which had white stones. And moreover, it was a counterfactually robust representation, meaning that you go in and find its little mental map of the board, which it came to itself through a training process, and you flip over a white stone into a black stone, and then it behaves as if that was a black stone. So it makes strategic moves and associations about legitimacy of moves. It makes all those predictions based on the altered board state that you injected into its mind. So it really is like counterfactually, causally, what's going on is this is an important bit of the prediction process, is to abstract this spatial representation. Now, let's recall what we talked about before. The Baldwin effect is a way to turn learned structures into innate structures. A practice that is both learnable with effort and highly advantageous once learned can become more and more easily learned, gradually transitioning into the status of not needing to be learned at all. So this is a kind of Lamarckian effect that we reviewed earlier in the talk about how learned things can become innate. But I just pointed out that Othello GPT learned a spatial representation. Consider now applying the meta-learning techniques that we've been talking about to Othello GPT. Its resulting spatial intuition that would eventually be Baldwinized because it's a helpful thing and it would be better to learn it sooner, or it'd be even better to know it from the start, isn't some magical a priori gift. By exactly the methods I've been describing, it's a highly efficient data processing strategy that got Baldwinized into an innate spatial faculty. Right? So if you are into this kind of thing, it is a naturalization of the Kantian categories and the spatial intuition in particular. Now, I should tread lightly here because Kant has famously argued that questions of genesis, the quid facti, the evolutionary accounts that I've been providing, cannot answer questions of justification. So I'm symbolizing that schematically as F does not imply J. If I had a quid facti account, I cannot get to a quid juris account from there. And this is partly a move to save objectivity because there has to be some improvement over the Humean program from the Kantian perspective, where the categories and intuitions aren't just customs and habits that we have, they are in a way, transcendental preconditions for any kind of rationality or experience or cognition, or like there's different ways of fleshing that out. Now, fair enough about the quid facti not implying the quid juris, but that doesn't mean we should stop caring about the quid facti. I do, in fact, want to naturalize Kant, at least in giving an origin story, maybe in addition to a quid juris story. Although maybe you don't need one. Well, that's for the person. That's for you to decide. Okay. I don't want skyhooks. I want cranes, in Dennett's terminology. So if X is some transcendentally necessary thing for rationality, then I want an evolutionary account of why that particular innate structure always evolved alongside or prior to rationality. So it's not that F gets us to J, it's that J needs an accompanying F. So any quid juris account, I'm going to demand it be accompanied by a quid facti account, and in particular one that I can make good evolutionary sense of. Now, this is, if you have a quid juris account, it must necessarily include and therefore lead to a quid facti account. Okay, that's my demand. But by a kind of contrapositive, and I don't mean it literally, it's just a kind of schema. Not F should imply not J. Okay, well, let's look around in logical space and try and figure out what that might mean. We just did this kind of formal trick, but what it means is that a quid facti limitation implies a quid juris limitation. So here's an example. Evolution has a constraint on it. It has to give a kind of gradualist account. And thereby, it's going to speak against a strictly binary characterization of our rational faculties. Either you have it or you don't. So if that's your kind of quid juris account, or that's an aspect of it, it's very hard to see how that could lead to an evolutionarily salient quid facti account. And so, therefore, I reject your quid juris account. Right? So limitations on the origin side, which are placed on us by evolutionary mechanisms, give limitations on what kinds of quid juris or validity or objectivity or universality results we might want on the other side. That's just a general bit of logic to frame what's coming. Because there's a kind of irony towards the Baldwin effect, which we've been discussing, in that you can get innate cognitive structures in this way, but you had to learn them first. So the innate faculty X had to originate in the Baldwin story out of individuals who didn't have X learning X. Just with Othello GPT. It originally had no spatial intuition, and then it learned one, and it got easier and easier to learn it until it became Baldwinized into an innate structure. Now, again, a quid facti limitation should imply a quid juris limitation, so let's search for one. If such a Baldwinized X cannot be unlearnable, or it cannot be a necessary precondition for learning, because it had to be learned in order to be Baldwinized, right? Now, what is learning here versus acquiring, and where's rationality play into it? This is all up for debate, and it's good to kind of try and settle these things, I think. But if we take a strong view that any kind of learning is a form of rational cognition, then the following claim, anti-Kantian claim, follows quite directly. A Baldwinized X, innate faculty of some kind or other, cannot be a necessary precondition for all rational cognition, because that would include learning by our stipulation. Instead, it's got to be that learning X is a necessary precondition for X to even become innate. Now, this is the irony I'm talking about, that innateness comes about through learning. It's just a little irony. Now, in the last little demonstration, I'd like to go to something a bit more radical, radically different space-time intuitions that we might have, or that different species might evolve. Now, my background is in philosophy of physics, and I think a lot about space-time dualities. You can look at the other talks on my YouTube page. I know that physics often admits two dual mathematical descriptions, and to explore the philosophical implications of this, I have been designing board games and video game concepts. And you can find them on my website, in fact. And I'm trying to get them coded up and maybe even release them on Steam at some future date, maybe. One game, which is fun, and I'm playtesting it now, so I'm looking for people to play it, is called Escher chess. It is a chess variant played on 2 boards. So I have my board and you have yours. And both of us are going to look at our boards and play a game calling out moves to each other, which we all both find interpretable and make the corresponding moves on our boards. I think I'm playing with normal pieces. When I look at my board, I see my knight moving like a knight. I see my bishop moving like a bishop, and everything's normal. But when I look at your pieces on my board, I see them moving very strangely. In fact, your knight moves like a bishop, and your bishop moves like a knight. And your pawns are very strange. They're unlike anything I've seen before. And your king's strange as well, it figures. So you've got very strange pieces. That's my phenomenology. That's what I make of the game. But now you, with your separate board, have exactly the same phenomenology without any reversal of roles. You think you have the normal pieces. You think I've got the strange pieces. We're both thinking I'm normal, that other guy's strange. Now it's set up, the detailed math behind the scenes, so that we agree about captures, we agree about when threats are happening, but we disagree, for instance, about adjacency. I might say to you, oh, it looks like your pawn is adjacent to your knight. And you will say, I have no idea what you're talking about, that is false. Right? So there's a kind of radical spatial redescription of the board which is happening, with some objective factors being preserved, but not all of them. Okay, so that's one game. I've made up other games. In particular, now I'd like to walk through a game called Parallax, which I have to switch to another slide deck for because Beamer doesn't do GIFs. So here is my slideshow for this. This is a little pitch deck that I made for the undergraduate video game development club. They're called Amorium here at Yale. I pitched this game to them. They liked it. But they only produce 2 games a year. It's a really great thing. They've got visual designers and music designers and narrative people and programmers and everything you need to make a very high quality game. And they make 2 of them per year. And it's a democratic process to decide which games are made. And my pitch came in 3rd. So I didn't quite get the army of undergraduates that I was hoping to work with to produce the game. But here's the game anyway. Here's my pitch deck for it. So again, it's a duality kind of game. So there's 2 players looking at different screens, and having totally different phenomenologies about the world, but they're somehow interacting with one world and have to learn to play the game together. Now, unlike the chess game, this one is cooperative, and it's a puzzle-solving platformer, if you're familiar with that kind of game mechanic. I've already introduced myself. The game's a bit like Portal 2. If you've played that game, it's a kind of cooperative puzzle-solving game. But we can jump straight into the gameplay here. So there are 2 dual perspectives on the world, one from Mobius and one from Euclid. That's named after the mathematics that's going on behind the scenes. So what Euclid is looking at is this field on the left here. He thinks I'm this little cylinder moving around in Euclidean space. I can run around left and right. I can jump. There will be objects I can jump on. If it was in VR, you would have a totally normal 3D phenomenology of walking around and bumping into things. Okay. Now, Euclid is not alone in his world. He has his friend Mobius here. And Mobius to Euclid looks like an infinite straight line, an infinite extended object out to infinity. Quite a strange friend to have, but there it is. Mobius, on the other hand, sees the world completely differently. Mobius says, I am not that weird infinite line you may think I am. I am this localized cylinder here. And I live on a Mobius strip. So it's infinite in one direction, up and down. But if I moved left and right, it's periodic, actually. And actually, the world flips over. If you walk around the Mobius strip in the periodic way, it flips over so that you come back on the other side from where you started. And so Mobius sees little ghost copies of himself inverted every other period, right? So it's a very strange kind of land that Mobius lives in. But again, it's a totally normal 3D phenomenology locally. I walk around, I bump into things. Like there's 2 dimensions of space and I can jump. And then there's time I move through. But Mobius says, Euclid, you are this strange wavy line that sits in front of me. Both players think they're localized cylinder objects, and they both think the other player is an infinite line-shaped thing. Let's now animate Here is Euclid moving around in his space. Again, completely normal phenomenology from his point of view. Mobius sees the corresponding squiggle doing strange coordinated motions while Euclid does his little dance. Okay? If we do it the other way, here is Mobius moving around along with his little ghost copies that he sees of himself in the distance. But the corresponding line in Euclid's world does all kinds of strange coordinated transformations in the meantime. So there's a one-to-one map between their worlds, but they have radically different intuitions about what's local, even what's mereologically simple. I say that I have no parts, and you say that I'm an extended object. It's quite strange. What do they do then? This is a game after all. Objects which Euclid sees as a plane and a cylinder here in his little world on level 3 look much more complicated to Mobius, and vice versa. But they still agree there is a blue thing, it is taller than the green thing, etc. Right? But they have to solve puzzles together ultimately. That's the point of the game. They have to communicate and combine their abilities to solve puzzles. For instance, suppose that Euclid's task was to jump up on top of the big blue plane. He has to jump on top of the green thing to do that. That's even too tall for him, so he has to first jump on top of Mobius and run along him like a fence. Right? So he has to ask Mobius to get into a position to make that happen. Euclid says to Mobius, go stand parallel to the blue plane on the other side of it. And Mobius looks at his view and thinks, I'm a point-like cylinder. What do you mean, go stand parallel to something? I see a blue thing, but what the hell do you mean by that? So that's the structure of the game. The two players have to somehow communicate with the objective features that they have, or come up with some kind of convention for the non-objective features, and sort out the world together. This was a pitch, so let me tell you finish the last slide. That's a cool mechanic, but what's the story behind it? Well, it's a philosophically very rich terrain to try and build a narrative out of. What is observer-independent reality? How can people with radically different perspectives end up working together? That's a bit more politically salient. And it leads to what I suggested to the Amorium Club, is a political allegory that the big bad is an oligarch who has intentionally fractured their views of reality in order to control them. It's left versus right, whereas it should be top versus bottom, right? And we have to come together, reconcile our differences, and overthrow the system that divides us. But not by agreeing to one of our ontologies or the other, because they are radically different and we both feel completely natural in our own ontology. We have to come to somehow legitimize and respect each other's differences to make it all work out. Okay, that's the pitch deck for the game. And again, I would have the Amorium people make really fancy graphics and do a wonderful narrative, and this is really fruitful ground to build on. But back to the Beamer presentation. So you could imagine evolving an LLM in just the same way we did before in the Escher-Chess context or in the parallax context, and they would adapt themselves to the particular spatial intuition which is fit for their purpose and fit for their existence. And it's an important fact that evolution is substrate independent, so that Euclid can look at Mobius and say, oh, I see the kind of creature you are and how you move around in my, phenomenology. And I see why it would make sense for you to evolve that weird kind of spatial intuition that you did. And yeah, okay, I can see how you would see the world that way. And Mobius says the exact same thing to Euclid, right? Both may be thinking that they're wrong about the fundamental nature of the world. So these divisions in the parthood relation, the mereology in particular, are suggestive that we really don't have access to any kind of noumenal description. So it is a very Kantian program ultimately, in that the categories that we're coming to arrive at us through a kind of evolutionary thing in a way that secures a kind of divorce from the noumenal. And at most there's some structural aspect, maybe a structural realism, that we are characterizing in different ways, representing that same structure with different kinds of phenomenology. So at most you could get a structural realism, but probably nothing more than that, if you really buy into this kind of evolutionary origin for our concepts, and the possibility of alien ones. not possibilities in the actual world, like we could go find them, but like even just the mere conceptual possibility of these shows in a way that the evolutionary thing isn't tracking any kind of noumenal structure or specific ontology out there in the world. It may track a structure, if this is how you get kind of an epistemic structural realism, but it probably won't track specific ontology because that's not relevant for survival, and it's potentially representable in multiple ways. Okay, to close up the talk, there is a nativist historical legacy, there is an empiricist historical legacy. They both have their favorite AI techniques, which is either the good old-fashioned AI on the nativist side, or now the neural networks and connectionism of empiricism. My goal is to take the methods that the empiricist has been using thus far and take them, apply them to nativist ends, and then bounce that up in a little diagram up into a philosophically interesting discussion of space and time and all of our innate categories, including universal grammars and potentially later Jungian archetypes. But you can do so much with this doing, again, evolutionary epistemology in silico. In sum, we could leverage meta-learning techniques to efficiently and faithfully simulate the exact same kinds of evolutionary pressures that shaped human cognition. We can evolve a language acquisition device in large language models in very satisfying answer to Chomsky. We can evolve a spatial intuition into a transformer. This is what Othello GPT showed. And there's lots of connections to come out here about scientific realism and structural realism. About monism or dualism. There's really lots to say here, which I'm working on. And different species might evolve radically different spatial intuitions. I'm not trying to make a claim that the quid facti answers any quid juris questions, but rather that quid facti limitations imply quid juris limitations. So even if you want these notions of objectivity or universality, you're going to have to make evolutionary arguments to show, for instance, that they are objects of convergent evolution. Right? You need some kind of demonstration of that. Whereas implicitly, it seems, with these radical spatial intuitions anyway, there seems to be quite a variety of different aspects. And also in the language evolution case, ultimately it will be a co-evolutionary story about how language evolves alongside the language faculty, and there's so much contingency there. What ends up as an impossible language in one evolutionary run might not be an impossible language in the other because different canals develop. So objective things about impossible languages and such may be difficult to get. Well, we have to do the empirical investigations. The whole purpose is to say now we can. So let's get out there and do a lot of empirical investigations and do some real good empirical cognitive science and philosophy. So thank you for your attention.